Now we are going to apply the 5 tests for proving congruent triangles onto example 1. Okay, let's read example 1. In the following diagram, we are supposed to name the pair of congruent triangles, identify them, and we are supposed to give the reason why they are congruent. So this is in a way proving that what we identified is indeed congruent. So let's look at part A. From part A, we can tell that triangle PTQ has the same length, corresponding sides with the same length. So these are the congruent triangles that we are going to prove, okay? So let us write down the reasons. Now, PT is equal to ST, okay? So this is given from the diagram, okay? And next, PQ is also equal to SR, given, okay, because it's directly given in the question, so we can just say given. And QT also has the same length as RT. Again, it is given in the question. Therefore, we can conclude that triangle PTQ is congruent to triangle STR. Okay, so notice that my sequence has to match. Okay, so the test that I'm using is SSS. Okay, so I have to state the test that I have used. So this is what giving reason for congruency will look like. Okay, you need to have 3 evidences and 1 conclusion with the test that is stated. Let's look at the next question. Okay, the next question, there are only 2 triangles in the diagram. So I can see that there is a right angle. So this is a very distinctive type of test. There's a right angle and they share a hypotenuse. So the hypotenuse is always directly across the right angle triangle. Okay, directly across. And then I have another side that is the same. So I'm going to apply the RHS test. And I need to work towards proving R and H next. So firstly, I have angle BAD, okay, which is the right angle, is the same as angle B, okay, the sharp end B, C, and D. So as I'm writing, I have to match the vertices as well. And this is given to be 90 degrees, okay, from the question, which is actually my R, okay. The next thing is my H. So according to the diagram, BD is equal to, on the other triangle, it is also called BD, and B metric B, D metric D. It's okay to write this, okay, because whatever is on this side is one triangle, whatever is on this side is the other triangle, and both of them have BD, okay, and we call this the common side. Okay, so it's not exactly given as in like given with strokes to say that they're equal, but because they're common, so we can deduce that they're equal, so we give the reason common side. So not everything is given, okay? So the last thing is your S, which is a side that is given to be the same. So this one is given to be the same with a little stroke as a symbol to represent that it is equal. AB, A is the side, it's the vertices with the right angle, so I'll match with C, B, okay, A match with C, B match with B, and this is actually a given equal side. Okay, so therefore, triangle ABD is congruent to triangle CBD. Okay, so the test that I've used is RHS. Now, don't worry about the sequence here. Okay, you can always write it as another alternative sequence, which is BAD, for instance, okay, it's just that if you are to choose to write triangle BAD, then you will have to match on this side, B match with B, A match with C, D match with D. Okay, so you can mix up the sequence, but on the other end, it has to match. Now let's look at question C. For question C, there are also, again, only two triangles, so it's pretty obvious that they are going to be probably the congruent one. So let's check, okay? So firstly, again, I have a right angle, okay? So this is again like the previous example, I have a right angle. So now let's see whether I have a hypotenuse, okay? Now, directly across, I can see that I have a hypotenuse here, PQ, and I have another hypotenuse for the triangle at the bottom, TS, okay? Now, did the question say that PQ is equal to TS? Actually, the answer is no, okay? PQ is not given or can be deduced right away, okay, to be equal TS, okay? So they look the same, but there is no evidence given directly in the question. All they give is parallel, they are parallel, okay? So it doesn't mean that the question has tell you in any way that PQ is equal to TS, okay? So it seems like we are not able to use H, okay? We are not able to use H. So this seems to be not a RHS proof, even though there is a right angle, okay? It may not be an RHS proof. So in this case, because hypotenuse is not given or can be deduced by any property here, only that they are parallel doesn't mean they are equal. So let me change this angle back to just A. Okay? A, they are the same angle. That's all I know. They're the same angle. Now let's see whether there are any other sides that are given to be the same. I can see that there is a stroke that is given at PO, right? Okay, and there is another stroke that is given at RS. And what more is that OR is a common side for both triangles. So it seems that I can hence say that PR is the same as OS. Okay, so I have an S there. I have an A. Okay, I have an S. I have an A. So it seems like I need another A or S. Now, I haven't actually used the parallel line. So what can parallel line tell us? What can parallel line tell us? What is a distinctive angle property that parallel line can tell you? Something here? Okay, have you guessed it right? So basically there is another alternate angle here that is equal because there are parallel lines given. So it seems that I am dealing with A, S, A. Okay, A and then an S and an A. Okay, so that is the direction I am moving towards. So I'm going to write down the first A I have is, I will work on the alternate angle first. QPR, okay, is equal to angle, okay, Q match with T, the tip of the parallel lines, okay, T, and P match with S, and R match with O, okay, so this is my alternate angle because PQ is parallel to ST. Okay, so this is my first A. Next, I have a side that is the same, okay, PR, or PR, okay, PR is equal to my SO, okay, that is because OR is common and PO is given to be SR, the same. So PR is equal to SO. Okay, so I have a side. Now I have another angle, the right angle, okay, which I haven't said, so I'm going to write it now. Angle QRP is equal to angle TOS. Okay, so this is a given 90 degrees. So therefore, I can conclude that triangle QPR is congruent to triangle TSO. Okay, and the proof that I use is ASA. Now, there is an important lesson learned here for this question is that, okay, it doesn't mean, okay, let's write down here, 90 degrees given doesn't mean that it has to be RHS test to be used. Okay, it doesn't mean that, because in this case the H is the missing link. There is no given info directly that PQ is equal to TS. Okay, so this is a note here. Okay, it can just be the R here in this case is just an angle. Let's look at the last question for example 1. Again, example 1, there are only 2 triangles here. Okay, but let's see how I can prove that they are congruent. Basically, again, I have a parallel line. Okay, and this time around the parallel lines are said to be the same, equal length. Okay, so there are 2 informations there, and parallel lines will usually tell you about the angle property, which is that there is a alternate angle. Okay, alternate angle. So I would think that B is going to match with E. Okay, B is going to match with E, and I have another Z over here. Another Z over here. So I can also say that there is another equal angle over here. Okay, so basically I can be using my ASA test, okay, my ASA test to show that these two are congruent. Now there can be another alternative, because some of you may be thinking of using the vertically opposite angle, and then you can use AAS as well. Okay, it can be also a AAS. So there are 2 methods. It's either you are using an ASA or you're using an AAS, okay, with a vertically opposite angle. Okay, so anyway, I will be choosing one, ASA. Okay, so I will be choosing the ASA to explain why, but both of them are possible. So firstly, I'm going to start with an A. I'm going to start with BAC. Has the same angle as angle BAC, and is equal to EDC. Okay, because B match with E, and this is because there is an alternate angle due to AB parallel to DE. Okay, so even this one matches as well. Okay, so I have an A here. Next, I have a S to prove. So AB is given to be 3 cm and DE is also 3 cm. So this is a given to be 3 cm. Okay, and the last thing is a A. The last evidence I need is a A. So I have another angle ABC is equal to angle, okay, ABC, this one, is equal to angle DEC. Okay, so whenever I write this down, make sure it matches. So you have to be careful when you label the sequence of the letters of the vertices. So in this case, it is also an alternate angle with AB parallel to DE. Okay, so therefore, the 2 triangles that are congruent are ABC and DEC. So the test that I've used is SAS. Okay, so there you go. This is how we can apply 5 tests to the diagrams to prove that there are congruent triangles. Okay, so this portion is already included in the first video on why SSA or ASS is not possible, so please refer to the first video. Okay. Now let's look at the second example on a more complicated diagram on how we can prove, okay, that the triangles within the diagrams are congruent. Okay, so before that, let's read the question. Okay, this is very important, is to read the question carefully. So basically they tell you that ABCD is a square. So there is an information given about the length of this diagram. Okay? Now they also say that E is the midpoint of CD. So sorry, F is the midpoint of CD. So basically there is also two equal lengths here. And they say that BF is perpendicular to EG, so there is a 90 degrees here, which also means there's another 90 degrees here, and BCG is a straight line. So over here I have a straight line. Okay, I have a straight line. Now let's see how we can work on DEF and CGF. Okay, so for clearer visualization, I'm going to shade the triangles that we are looking at. So these are the triangles that we are going to focus on. Now if I look at these two triangles and I'm supposed to prove that they are congruent, so what can I use? Can I use SSS? Are all the length given? Okay, be careful that there are lengths that will look the same, right? But they are not directly given in the question. So I cannot say that it is given. No way. Okay, so what is given is more of, okay, the midpoint, that F is the midpoint of DC, and this is given, directly given, so we can use this later. So it seems like I have a side to play with. Okay, I have a side to play with, corresponding sides. And what else do I have about these two triangles? Notice that they tell you that it's a square, isn't it? It's a square. So there is an information here, okay, that is directly given, or you can deduce it. That is that you have actually a right angle. Okay, there is no assumption that it's really because it's a square that there is a right angle there. So looks like I have a angle or a right angle to play with. So since this is about right angle, now we are going to decide whether this EF and FG, are they given, this hypotenuse, are they directly given in the question that they are the same? Look at the question again. Okay, the answer is no. Okay, I cannot use the hypotenuse because this is not given. Okay, cannot say EF is equal to FG yet, because there is no link or whatsoever in the question that tells me directly. So I cannot use this H. So it seems like, again, it is not, okay, this is our hypotenuse. So since we cannot use this, so it is not going to be a RHS test. Okay, so this right angle is just an angle that we're talking about. So I have a side also. So let's see whether there is any other possible angle or side that I can use. Since I cannot say that CG is equal to ED because it's not given, I cannot say that hypotenuse are the same. So it seems like I'm only left with, okay, there is a vertically opposite angle. That is indeed true because there are two vertically straight lines. Okay, so I can deduce this using shape properties. So in this case, I'm going to write that angle EDF is equal to angle GCF. Okay, this is my, because it's a square, so I know that they are 90 degrees. Okay, now the next thing is I have an S there. Okay, I'm heading towards ASA. So the next step is my side that I want to talk about. DF, okay, is given to be CF because matching the points, the question did say D match with C, okay, and the question did say that F match with F. So DF equals CF, and it is given to be so because they say that F is a midpoint of CD. Okay, so I have to be very specific. You cannot always say given. Okay, if the question did give you something more than that, you have to state out what is the property that you're using. So after DF equal to CF, okay, I have another angle to touch on. Angle EFD is equal to angle, okay, EFD. I'm talking about the vertically opposite angle here. GFC, okay, match them using the question. So in this case, this is a vertically, okay, I'll write short form. You are allowed to write vertically opposite angles. Okay, so therefore I can conclude, after I have three evidence, I can conclude that therefore DEF is congruent to CGF, and this is my ASA test. Okay, so this is proving the first part. Okay, so I'm done proving the first part. Now, let's look at the second part. The second part wants you to prove another two triangles. So I'm going to shape these two triangles again. Okay, I'm going to erase a little bit on what I've drawn. Okay, so that it's not so messy. Okay, so basically the next two triangles that I'm looking at is BFE. Okay, a big one on top. And BFG. Okay, the one that is at its side. Sorry. Okay, the one that is at its side. Okay, so I'm looking at these two triangles. Now, please remember something. As long as you have proven something in part 1, okay, if you need this result in part 2, you can always use the result here back in part 2. Okay, so later there will be something that we can show you about how we can use part 1 and part 2. So over here, okay, let's figure out first now which test we're going to use. We have a perpendicular clue that we haven't used. Okay, so there is something about this perpendicular that I can use about these two triangles. Okay, so once again I have to think about it. Since this time round is a right angle, am I going to use RHS? So let's zoom in at our hypotenuse again. Okay, if we look at our hypotenuse, is it given that BG is equal to BE? Look at the question. Directly, it is not given again. Okay, cannot say BE equal BG because no direct condition or no direct clues stated. Okay, so there's no way to infer. Of course, they will look the same because in the end, you're supposed to prove that these two triangles are congruent. Okay, but if they never say it, pretend that you don't know. Okay, it's not. So I can't use H. So again, it is not an RHS that I'm working on. So these they are just angles that I will be using in the test. So let's see what else I have to say. Now, because these two triangles join together, in fact, joining together, there is always something that you can use if they join together. In fact, we have seen this in part B here in example 1, where I have two triangles that join together. So this is a very useful trick, which is to use the reason common sign. So I'm going to go back to example 2 and let you see that these two big triangles, they have a common side that we can play with. So here I have actually a common side S. So I have S and A. So is there another side or another angle that I can work with? Now, if you look at these two angles, now again obviously they will look the same because you're supposed to prove that in the end they are congruent. But look at the question again. Look at the question. Is there anything about these two angles being the same straight away? Okay. You can't even tell whether this is isosceles because they didn't say that EB is the same as GB. Okay. So there is no way to tell whether these two angles are the same. But from part 1, remember? Okay, from part 1, you have proved that these two triangles are congruent. Which also means that because part 1 you proved that they're congruent, you can now say that these two lengths from that congruent triangle that you have proven can be used because they are the same. Okay, so you can hinge on part 1. So I have a side that I can play with. So I'm heading towards a SAS test. Okay, so firstly, the first S that I'm going to use is EF is equal to GF. Okay, again I'll match the points based on the question. And EF is equal to GF because it has been proven in part 1, right? Okay, it has been proven in part 1 that triangle DEF is congruent to triangle CGF. Now, in part 1, we didn't use these two as in our evidence because it is not proven yet. But after we have proved this, we can now say they are the same. Okay, so this is proven. So we write this as the reason. I have an angle EFB that is given to be the same as GFB. Okay, so this is given to be 90 degrees, and because it is an angle on a straight line, that's why I can deduce that the other angle is also 90 degrees. Okay, so I'm going to write down the reason. So the last reason is the trick that I mentioned about the common sides. BF is the same as BF. Okay, because it is joined together, so I can hinge on this common side reason. Okay, so this is the SAS. Therefore, I will conclude that triangle BFE is congruent to the triangle BFG. SAS. Okay, so this example shows you that you can apply the aftermath result from part 1 into the next part, okay, to help you in further proving of congruency. That's it for applying congruency tests into the questions. In the next section, we are going to look at proving for similar triangles.